Next we have the fifth exercise, and in this a new unit of length has been chosen so that the speed of light in vacuum is unity, that its numerical value is 1. Then what is the distance between the sun and earth in terms of this new unit if light takes 8 minutes and 20 seconds to cover this distance? So the solution starts like this. What is the time given for light to cover this distance? 8 minutes and 20 seconds. So we convert this 8 minute into second by multiplying it by 60, and then the total becomes 500 seconds. And what else is given? It is given that in the new unit of length, the speed of light is 1. That means it will look like this. V equals 1, the new unit per second. So obviously in the new unit, the distance between the sun and earth would be V times this T. So that means 1 times 500. I am talking about the numerical values. So it is 500 unit. Second and second will cancel each other and we will be left with unit because this is distance. So next we have this 3 devices, and we are being asked to ascertain which one will measure length most precisely. Which of the following is the most precise device for measuring length? A vernier calipers with 20 divisions on the sliding scale. You know that in a vernier caliper there is a main scale and there is a sliding scale or vernier scale. So that sliding scale has 20 divisions. And in B there is a screw gauge with pitch 1 mm and with 100 divisions on the circular scale. And in C there is an optical instrument that can measure length to within a wavelength, one wavelength of light. Because optical is given, so we are talking about the visible spectrum. In order to decide which one of the 3 instruments is the most precise, you have to calculate the least count of each one of them. And least count you already know, but again I am saying least count is the smallest measurement that you can make with an instrument accurately without guessing anything. So for vernier calipers, that least count is this: 1 main scale division minus 1 vernier scale division. Now what is this 1 main scale division? Main scale division is the distance between 2 nearest graduation marks, those small marks that you have on the scale. That is the least distance that the main scale, if it is used alone, can measure accurately. And similarly, 1 vernier scale division is the distance between 2 nearest graduation marks on the vernier scale or the sliding scale. So it is, least count is 1 main scale division minus 1 vernier scale division. Now usually this is how they are linked. N minus 1 main scale divisions equal n vernier scale divisions, where n can be any positive integer. So if I call 1 main scale division n and 1 vernier scale division v for notational simplicity, then this is how the equation looks. N minus 1 times m is equal to n times v. V stands for vernier, or nm minus m, that is equal to nv. Now if we switch sides, nm minus nv equals m, and if you take n common out, then you get m minus v, that is equal to m, and then you divide both sides by n. So that way you get m minus v equal to m divided by n. What is m minus v? M minus v is actually this: 1 MSD minus 1 VSD, or least count. So in that way you have found a simple formula for calculating the least count of vernier scale. Vernier calipers, same thing. And what is that? That is the number of divisions on the vernier scale that you will here have in the denominator, and in the numerator 1 main scale division, that is the distance between 2 nearest graduation marks on the main scale, which for ordinary scales is 1 millimeter. and that is why now we have this. So the least count of the vernier calipers with 20 divisions on the sliding scale or vernier scale is m divided by 20. In this case, in this problem, n is 20, and in place of m you have 1 millimeter. So that's how you will have the least count. So if we use the value of m, that is this 1 millimeter, the least count of our vernier scale turns out to be 0.05 millimeter. Next comes the least count of a screw gauge with those specifications, that pitch is 1 millimeter and there are 100 divisions on the circular scale. The least count of a screw gauge is the pitch, its pitch divided by the number of divisions on the circular scale. So it's already given to us what these two things are for the type of screw gauge that we are considering, where pitch is 1 millimeter and there are 100 divisions on the circular scale. So the least count for such a screw gauge is 0.01 millimeter. You can already see that the least count of screw gauge is less than the least count of vernier scale. So this one is more precise than vernier scale, but there is a third one also, that optical instrument. And the third device is some kind of optical instrument which can measure length to within one wavelength of light. Now light means visible light, and you know that visible light does not have a single wavelength. From violet to red, there are lights of different wavelengths, and these different wavelengths are perceived as different colors by our eyes. Nature is wonderful. So it is a range rather than a single real number. It's an interval of numbers, and the wavelengths lie in this range between approximately 400 nanometer to 700 nanometer. So how to change these nanometers to millimeter? Because then only we can compare this range somehow with those two numbers, 0.05 millimeter and 0.01 millimeter. 0.05 millimeter, that means vernier scale has already lost the race, but now we have to see this one. Obviously it will be less than that, but still. So here are your submultiples of 1 meter. First comes decimeter, then centimeter, then millimeter, followed by micrometer or micron, and then nanometer. So as you start from 1, you keep dividing by 10 each time you get a smaller unit. So that's how you get 10 to the power minus 1, minus 2, minus 3. But after that, you have to keep on dividing by 1000, not 10. So after minus 3 comes minus 6, minus 9, and that's how it goes. So this is your nanometer and this is your millimeter in terms of meter. So in order to, I mean, do you see the difference, or rather multiple of 10 that you have between millimeter and nanometer? 10 to the power 6, or more accurately 1 millimeter equals 10 to the power 6 nanometer. Obviously here the exponent 6 will be positive because this is a smaller unit. So this many nanometers equal 1 millimeter, or 1 nanometer, if you divide both sides by 10 to the power 6, is 10 to the power minus 6 nanometer. So this means that in order to convert nanometer into millimeter, you have to multiply by 10 to the power minus 6 these values. So when you do the conversion, you multiply by 10 to the power minus 6, then nanometer gets converted into millimeter. And after cancelling the zeros, you already know, this is how you get the figures. 4 times 10 to the power minus 4 millimeter to 7 times 10 to the power minus 4 millimeter. Obviously this range has values no matter whatever wavelength you choose from here, that is smaller than 0.01 millimeter and obviously smaller than 0.05 millimeter, much smaller. That is why this optical instrument is the most precise. So the correct answer is C.